The non-parametric equivalent of the repeated measures ANOVA is Friedman's ANOVA or the Friedman analysis. So if an assumption of the repeated measures ANOVA is violated, you can perform this analysis instead. The formula for this analysis is FR equals 12 divided by NK multiplied by K plus 1. And this fraction is multiplied by the sum of squared ranks minus 3 capital N multiplied by K plus 1. And capital N stands for the number of participants, the number of test subjects. K stands for the number of measurement moments, and in this case, K equals 3 and N equals 5. We will work with an example regarding repeated measures. The table shows the values for 5 participants at measurement moments 1, 2, 3, or Y1, Y2, and Y3. And in order to perform the Friedman analysis, we need the sum of ranks. In this case, however, the ranks are within subjects and not between subjects because there were repeated measurements. We compare participants with themselves at different measurement moments. You will now check for each person whether they scored highest at Y1, Y2, or Y3. And if you look at the first person, you will see that they scored the lowest at Y1. So this value is therefore given rank 1. The first person scored medium at Y2 and highest at Y3. And that is why this last value is given rank 3. And you're going to enter these ranks for the in the table for each person, as I'll do here now quickly. And if we then fill in the formula, we will start with the first fraction. The first fraction is 12 divided by nk multiplied by k plus 1. N stands for the number of participants, which is 5, and k is 3. So this is 5 times 3 times k plus 1, where k plus 1 is equal to 3 plus 1. 5 times 3 is 15, and 3 plus 1 is 4. 4 times 15 is 60, and therefore the first fraction equals 12 divided by 60, which equals 0.2. Then we need the sum of squared ranks, and this requires the sum of ranks. Add up all ranks of the first measurement moment, so y1, 1 plus 1 plus 2 plus 1 plus 1 will be 6. For the second measurement moment, y2, this will be 2 plus 3 plus 1 plus 2 plus 2 will be 10. And for the third measurement moment, y3, the sum of ranks equals 14. Next, we square these three values and add them together. This will give us 6 squared plus 10 squared plus 14 squared, which is equal to 36 plus 100 plus 196, will be in total 332. Now, we have to fill in this value in the formula of FR that we already started with, and then this formula becomes the fraction multiplied by 332 minus the last part of the formula. The last part of the formula is 3n times k plus 1. N is 5, so that will be 3 times 5 times k plus 1. K is equal to 3 because there were 3 measurement moments, so that becomes 3 plus 1 is 4. And then the last part of the formula is therefore 60. And therefore, FR equals 0.2 times 332 minus 60, which can also be 66.4 minus 60 will be equal to 6.4. And therefore the test statistic is equal to 6.4. The Friedman analysis uses a chi-squared distribution, which means that the degrees of freedom are calculated with the formula k minus 1, where k stands for the number of measurement moments. And in this case, there were 3 measurements, so the number of degrees of freedom will be equal to 3 minus 1 equals 2. And with the test statistic and these degrees of freedom, you can find out if there are significant differences between the 3 measurement moments.